Hello everyone, I'm Joseph with Nance International HVACR Services in Beaumont, Texas. Please follow and subscribe with us, and hopefully this is one of many of the videos we'll be hosting over the next near future. Today we're going to be describing subcool, and again subcool by definition is 1 degree below its condensing point of a liquid. And with subcooling, we're working with liquid refrigerants that are in a liquid state. To check subcooling, the only place we have subcooled liquid in a refrigeration system, be it air conditioning or refrigeration, is going to be on the outlet of the condenser on the liquid line that leads up to the metering device. So whenever we check subcooling, we will be on the liquid line. And the liquid line in this instance is going to be the smaller of the two pipings that's on a refrigeration system. So initially what we'll have to do is get a saturated temperature of the liquid that's in the condenser. And the condenser by name is on the discharge or high side of a system. So the first step we need to do is to inspect our gauges, hoses, and associated equipment to make sure they're in proper working order. We have no leaks or in our piping or our hoses. And to check subcooling, what we'll do is take off the discharge, or it would be your right and my left. This gauge is the high side or discharge side of the refrigeration system. And I will remove the gauge hose set from the high side of the system, making sure that our manifold gauge is secured. And as I mentioned earlier, the piping I'm looking for is the smaller of the two, which is the discharge piping. Remove the cap very gently, making sure that there weren't any leaks on my access valve. Use one hand, and I'm connecting the hose up to the high side of the system as we speak. And now that I have my hose connected, what I'm going to look for now is the saturated pressure. And as you notice, the pressure is increasing on my manifold gauge. So I will use this pressure that's on the manifold gauge, and I will convert it to temperature by the use of a pressure temperature chart. For every PSI on this gauge designates a specific temperature. And unfortunately on this manifold gauge we don't have a temperature scale for the 407C refrigerant that's in this system. So I'll walk over to a pressure temperature chart and get the pressure for 210 PSI G. And my refrigerant in this column on the right side at 210 PSI G, we don't have exactly a temperature pressure that matches up to 210. So what I'm going to do is use the closest one I have is 215.8 PSI G, and that converts to about 98 degrees Fahrenheit. So I need two temperatures, one for my pressure temperature chart, which is 98 degrees Fahrenheit, and then I will take the actual physical temperature of my piping and I will subtract those two numbers and I will come up with a designated degree of subcooling. To get the physical line temperature that I need, I will use a thermocouple, and I'm using a fill-piece thermometer that I have a readout on my degrees, and it's in Fahrenheit. So I'll place the clamp or the probe on the liquid line. And I'll give it a few moments to stabilize its temperature that I'm looking for. And as you can see, the temperature is bouncing around just a little bit. It's about 76.5, 76.4. So let's just call it an even 76 degrees. And again, the other temperature I need is from my saturated pressure. And on 407C, it was about 90 degrees for a pressure of 210. And I will subtract those two measurements, and as you see, I have almost 17 degrees of subcooling. Now, from equipment manufacturer to manufacturer, that target point of subcooling may be higher or lower. So please use the manufacturer of the equipment as reference if necessary. And we're fortunate in some cases where on the equipment, the label on the equipment will designate what that subcooling should be. And again, we use subcooling when we have a thermostatic expansion valve or an automatic adjusting metering device. Is when we use subcooling as a set point. And that's what we've done today. And again, I hope you enjoyed this video, and I hope you were able to get a better understanding of what subcooling is and how to check it. So thank you very much for watching.